Hi, welcome to Sunil Maths tutorial. Let us learn about continuity in functions of several variables. Let us take, suppose f of x comma y is any function defined over two variables. This function f of x comma y is said to be continuous. F of x comma y is said to be continuous at any point a comma b of its domain of definition if it satisfies the condition limit x comma y tends to a comma b f of x comma y is equals to f of a comma b. So the function f of x comma y is said to be continuous at the point a comma b if it satisfies this condition limit x comma y tends to a comma b f of x comma y is equals to f of a comma b. You can rewrite the same definition like this also. The function f of x comma y is said to be continuous at a comma b if for each epsilon greater than 0 there exists a neighborhood. For each epsilon greater than 0 there exists a neighborhood capital N of the point a comma b such that mod f of x comma y minus f of a comma b is less than epsilon for all the points x comma y belongs to capital N. Both are equivalent definitions. So you observe that the function f of x comma y is said to be continuous at a comma b if limit x comma y tends to a comma b f of x comma y is equals to f of a comma b. Otherwise, for each epsilon greater than 0, there exists a neighborhood capital N of the point a comma b satisfying the condition mod f of x comma y minus f of a comma b less than epsilon for all the points x comma y belongs to capital N. If these conditions holds, then we say that the function f of x comma y is continuous at the point a comma b. At the point a comma b. Let us see some examples to understand this concept. Suppose f of x comma y is equals to defined like this: x square minus y square by x square plus y square if the point x comma y not equals to 0 comma 0, 0 if the point x comma y is equals to 0 comma 0. It is very clear. From this definition we conclude that limit x comma y tends to 0 comma 0 f of x comma y does not exist. The limit at 0 comma 0 does not exist. Therefore we conclude that f of x comma y is not continuous. F of x comma y is not continuous at origin at 0 comma 0. Let us see one more example. Let f of x comma y is equals to x square plus 2y if x comma y not equals to 1 comma 2, 0 if x comma y is equals to 1 comma 2. Now calculate their limit. Limit x comma y tends to 1 comma 2 f of x comma y is equals to limit x comma y tends to 1 comma 2 x square plus 2y. So you simply get 1 plus 4 which is equals to 5. But f of 1 comma 2 is equals to, by definition it is 0. F of 1 comma 2 is equals to 0. Therefore we conclude that limit x comma y tends to 1 comma 2 f of x comma y not equals to f of 1 comma 2. Therefore the function f of x comma y is not continuous. The function f of x comma y is discontinuous or not continuous at 1 comma 2. At 1 comma 2. Here the point 1 comma 2, here the point 1 comma 2 is the point of discontinuity. The point 1 comma 2 is known as the point of discontinuity. Point of discontinuity of the function. That's it. Now let us check one more example to understand this concept. Let us take the function example number 3. The function f of x comma y is given by xy by square root of x square plus y square if the point x comma y not equals to 0, 0 if the point x comma y is equals to 0. So let us take x is equals to r cos theta, y is equals to r sin theta. Then then mod xy by square root of x square plus y square is equals to mod r cos theta r sin theta divided by square root of r square cos square theta plus r square sin square theta, which is equals to mod r square sin theta cos theta divided by r into square root of sin square theta plus cos square theta. The denominator completely, this term completely becomes 1 and r square get cancelled. You simply get r into mod sin theta into cos theta. Both sin and cos less than or equals to 1. So which is clearly less than or equals to r, where r means square root of x square plus y square, which is less than epsilon if it satisfies the condition x square less than epsilon by 2 and y square less than x square less than epsilon by 2 and y square right epsilon square by 2, and it is less than x is less than epsilon by or mod x is less than epsilon by root 2, y mod y is less than epsilon by root 2. It's very simple by removing the square roots. Thus we conclude that mod xy by square root of x square plus y square minus 0 is less than epsilon when mod x is less than epsilon by root 2 and mod y is less than epsilon by root 2. This condition shows as limit x comma y tends to 0 comma 0 xy divided by square root of x square plus y square is equals to 0. It means limit x comma y tends to 0 comma 0 f of x comma y is equals to f of 0 comma 0. This is nothing but the continuity condition. Therefore, we conclude that f of x comma y is continuous. F of x comma y is continuous at origin. F of x comma y is continuous at origin. That's it. In the next video, we learn two more examples depends upon the same continuous functions.